Ma'am, yes, ma'am. You can start now.
Morning vibes. Start with a positive mind. Happy morning to all with great joy and immense pleasure. I feel delighted to extend my warm welcome to all presented here for the science webinar. Change can be accomplished most of all through the power of prayer, because with God, all things are possible. So, let us initiate this webinar with a prayer song to get the blessings of the Almighty. A warm welcome is not just a welcoming smile, but it is a good start. I am well pleased to invite our Vice Principal, Mrs. Argita Ma'am, who has created a safe learning environment and set performance goals both for students and teachers to succeed, to give welcome address followed by the introduction of chief guest.
Thank you, ma'am. It's glad welcome we bring to you this morning, filled with the desires, hopes, and dreams we all share. It's my privilege to welcome our Honorable Chief Guest, Dr. S. Devashankar, MSc MPhil, PhD, Assistant Professor, Department of Physics, respected Trustee, Sri K. Rajesh Kumar Jain, TCO Sir, Principal, parents, teachers, and my dear students. Welcome you all for this beautiful occasion. It's my immense pleasure to introduce the chief guest of the day, Dr. S. Devashankar, MSc MPhil, PhD, Assistant Professor of Physics, Loganathan Narayana Swamy Government College, Ponneri, Tamil Nadu. Sir is having 27 years of experience in teaching field and 16 years of experience in research field. As well as Sir is a research supervisor in Anna University, Chennai. He has completed his master degree in physics at A.M. Jain College in 1992 and his master of philosophy in nuclear physics at MS University in 2003. Sir has completed his doctorate of philosophy in crystal growth. Sir has a wide interest in areas like crystal growth, matrix, Forman suit, physics education, and so on. Not only that, Sir has authored numerous books and published several articles. Sir has honored with a lifetime membership from Indian Association for Physics Teachers, Kanpur, and Indian Society for Technical Education, New Delhi. Sir has acted as an examiner for Dr. MGR University, Chennai, Chief Examiner for Anna University, Chennai. In addition to that, Sir was the chairman of the board, Tiruvallur University UG examination for the year 2015 and 16. Besides that, from the year 2005 to 15, Sir was in selection committee member for PG and UG teacher at Velamal Group of Institutions. We are really honored to have you among us, Sir. Despite Sir's busy schedule, Sir has accepted our invitation. Thank you, sir. Once again, I welcome you all for this wonderful session and make this session grand success. Thank you. I welcome you all. Thank you. Thank you very much.
Thank you so much, ma'am. Science knows no country because knowledge belongs to humanity and is the torch which illuminates the world. I would like to call upon Mrs. S. Krishnalakshmi ma'am, Subject Head of Physics Department, to present a Science Club report.
Unmute. Yes, thank you, ma'am. Honorable Chief Guest, respected Trustee Sir, Trust Coordinator Sir, Principal Ma'am, Vice Principal Ma'am, my beloved colleagues, parents, and my dear students. Good morning to everyone present here. Science is fun. Science is curiosity. We all have natural curiosity. Science is a process of investigation. It's posing questions and coming up with a method. It's delving in. Learning science beyond the classroom has been the aim of our Science Association, inaugurated in the year 2010 with the motto "Where Discovery Begins." Vision: science education beyond classrooms. Mission: power through knowledge. Objectives of our Science Association: to kindle interest of the students, to sharpen scientific temper, to increase enthusiasm in science. Activities of our Science Club. During normal working days, every week Friday, fair activity is conducted by our Science Association. Students present the concepts actively. We also conduct a science quiz. Many of our students eagerly participated in various science competitions conducted by Vidya Bharati, VIT, CMC Hospital, District Science Center, Vellore, Ministry of Power, Government of India, NASA International Space Science, etc. And our students never failed to win prizes. In 2019, Vigyana Pradarshini, conducted by Vidya Bharati, 2 students from our school were selected up to national level. Science kit competition conducted by Vellore District Center. Our students won first prize in district level, also won second prize in district level science quiz competition. From November 2019 to March 2020, CMC Hospital, Vellore conducted various competitions. Our students from class 8 and 9 won many laurels. The feather and the cap was the first prize that was awarded to our school students who participated in a self-composed music and dance on the topic, "How can diabetes affect the heart?" The pandemic has been a great teacher. We grew better at listening, not assuming that everyone's realities are the same, and focusing on things that truly mattered above all. In spite of pandemic times, in 2020, our Jain School staff and students were not sitting idle. Along with academics, we involved our students in many activities and webinars. Science was also not left behind. We also went hand in hand with other subjects. Students eagerly participated in virtual science quiz and involved themselves in webinars on science in daily life, adolescence stress management, health and hygiene. This year, we are all planning to conduct science-based slogan writing, quiz on science and technology, science exhibition, debate on use of herbal medicine is better than modern medicine, technological advancement, good or bad. To conclude, we are ready to guide the ignited minds of our students. Scientists have become the bearers of the torch of discovery in our quest for knowledge. May this quest for knowledge be never ending among our students. Thank you.
Thank you, ma'am. Felicitation is inspiration and motivation to others. Now, I would like to call upon our trustee, Sri K. Rajesh Kumar Jain sir, who stands for the quote, "Anything is possible when you have the right people there to support you," to felicitate the gathering.
Respected Chief Guest, Dr. S. Devashankar,
Thank you, sir.
Assistant Professor of Physics in Loganatha Narayana Swamy Government College, Puneri, Trust Coordinator, Principal, Vice Principal, teachers, and my dear students. Good morning to all. Your positive action combined with positive thinking results in success. Science is everywhere. A student rides to school on a bus, and in an instance alone, there are many examples of technology based on the scientific method. The school bus is a product of many areas of science and technology, including mechanical engineering and innovation. The system of road, lights, sidewalks, and other infrastructure are carefully designed by civil engineers and planners. The smartphone in the student's hand is a miracle of modern computer engineering. Outside the window, trees turn sunlight into stored energy and create the oxygen we need to survive. Whether natural or human divide, every aspect of the student life is filled with science. Science education is one of the most important subjects in school. Due to its relevance to students' lives and the universally applicable problem solving and critical thinking skills it uses and develops. These are lifelong skills that allow students to generate ideas, weigh decisions intelligently, and even understand the evidence behind public policy making. Teaching technology, literally critical thinking and problem solving through science. Education gives students the skills and knowledge they need to succeed in school and beyond. In present global situation, numerous powerful technology have been developed to assist people in household and offices. Faster communication is made possible through mobile phones and internet. Don't limit yourself. Many people limit themselves to what they think they can do. You can go as far as your mind lets you. What you believe and remember, you can achieve. Good life is related to science. It is science that provides good life for everyone. Thank you. All the best. Thank you very much.
Thank you
sir.
very much, sir.
Tell me, ma'am.
Now, I politely invite our Honorable Chief Guest, Dr. S. Devashankar, MSc, MPhil, PhD, Assistant Professor of Physics, PG and Research Department of Physics, Loganatha Narayanasamy Government College Autonomous, Ponneri, to spark this occasion by his words on the topic, the world of science.
Ma'am, we will start the program.
Yes, sir.
Yeah, fine. So I'll just share the screen. If there is anything stop in between, please let me know. Okay. Is the screen visible?
Yes, sir.
Yeah, very good morning, Vanakkam. This is my style, and I'm very, very happy to be a part of this program. And see, first of all, I'm very excited in the sense the prayer song has taken me 30 years back. Okay. During 1991, when I was studying in A.M. Jain College, every morning around 8:30, we used to have this prayer, this song. So exactly 30 years back, I heard the song for the first time when I joined MSc Physics in A.M. Jain College. Thanks for recollecting my memories. And I'm much thankful to your school principal, trustee, treasurer, and all the other staff and students for giving me an opportunity to address these young students. So maybe I'll take around 50 minutes to 60 minutes time. And at the end of the session, we'll have for discussion. If any questions you want to get answered immediately, please unmute and you can ask me. Okay. Yes, Shamim Nisha, your raised hand. Okay, good. Yeah, this is the plan of the talk. We'll talk about some 14 or 13 things, how heat energy is transferred, what are the 4 states of matter, and exothermic, endothermic reaction, convection and its importance. If hot air rises, then why is it so cold at the top of the mountain? We'll talk something about non-Newtonian fluids. Don't worry about all these terms, okay? Sound and light, oxidation, Chereos effect, what science we can understand from crumbling a paper, and what are the references I've taken. And as usual, some 3 homework questions I'm giving. Don't worry about it, even if you're not answering. At least have a taste of the question. Then acknowledgement, what are the people who are responsible for this, and discussion. Finally, I'm going to place a request to your school, a small request. Yeah, we'll proceed. Now, what are the ways in which heat energy is transmitted from one place to another place? Any student in the group? What are the ways in which heat energy is transmitted from one place to another place? Students? Yeah, Induja, you can answer. Yeah, students, you can please answer. You unmute your phone and then you just answer it. Let us keep it.
Sir?
Yes, please.
Movement of air, by that the heat can be transferred.
Yeah, very good. That is called convection. I'm happy. Thank you. Yes, next up. Next up. Okay, fine. When you take, yes, students, please answer. Don't raise your hands. You can just directly answer. You unmute and answer, please.
Sir, conduction, convection, and radiation.
Excuse me, sir.
Very good. Conduction, convection, radiation. Yeah, give a good big clap for the student. I do not know the name, but still it's very interesting. Conduction, convection, and radiation. Okay, good. And now, that's what, you're correct. Fine. Conduction, convection, radiation. Can we do any simple experiment to demonstrate simultaneously all the 3 things in one experiment? Can you think of any experiment that shows all the 3?
By fire, sir.
Yeah, by fire. Yeah, very good. See, a very simple experiment. Every day our mother used to do the thing. Hope you can see the thing. Yes. I've just, in my thing, I have shown firing a matchstick. Okay. Firing a matchstick is a very simple example. Okay. You have the heat radiated. Okay. It does not require any material medium to transfer. And then hot air rises. Hot air rises. Cold air comes in. It is convection. And of course, the stick appears hot due to conduction. Okay, good. One more question. Both the stick head and matchbox side are made of same material, but why the matchstick alone burns? Why not the box side? Are you understanding my question? Yeah, please answer. Not necessary to raise your hand. I could not see you. You can just answer it.
Chemical reactions, sir.
Sorry?
Chemical reactions.
Yeah, chemical reaction. Very good, very good. It's a broad answer. See, actually, I think you are having the matchbox and matchstick. I'm showing that. The matchstick is having a material which is made of phosphorus, and the side of the matchbox is also made of the same material. But here, the composition is slightly different, and the amount of material present on the stick is huge. Yes, my Mrs. said only PPT is visible. It is not visible. I know you can. 1 minute. How do you escape? Stop sharing. Okay. I should give stop sharing. It is not. I just show that stop sharing. Yeah, fine. Fine. This is the stick having the material on the head. Same material, but somewhat composition is different because of friction. Because of friction. Chemical reaction, that's on one side. This is because of friction. Very good. Let me go for sharing again. I'm just talking between these two things. So the matchstick burns. Very good. So that just by burning a simple matchstick every day we are doing in our house. Okay, our mother or our sisters or our father, when lighting the stove, gas stove, they used to use this matchstick. Okay, just by using the matchstick, you are getting so much information. You can understand the concept of conduction, convection, radiation, friction. Okay, and exothermic reaction. Some students said it is a chemical reaction. Yes, it's an exothermic reaction. A lot of heat is produced. Okay, a lot of heat is produced. So much, 5 reactions or 5 concepts you can understand from one single experiment. It's a very simple experiment. Of course, be careful while doing the experiment. Okay, unless until your parents or teachers are there, you should not do that. Okay, without their guidance, you should not do it. It is very dangerous with fire, whether it is small or big. Good. Next, we'll proceed. So the next one is, next thing is just a minute. It's obstructing my view. What are the different states of matter under normal condition? Any student, please unmute.
Solid, liquid, gas. Solid, liquid, gas, sir. Solid, liquid, gas. Solid, liquid, gas. Solid. Plasma.
Yes. I'm getting a wonderful response. Yes. Solid, liquid, gas, and plasma. Okay, good. So, yes, very good. Solid, liquid, gas, and plasma. Can you show some simple experiment to show all the 3 states of matter in one place? Some simple experiment to show all the 3 states in one place. Can you show some simple experiment? Can you show? Boiling water, very good. Srividya's answer is boiling water, very good experiment. When you boil water, you get 2 states of matter, liquid, vapor. Yes, participants, you can directly answer. Ice cube, yes. Akshaya, yeah, ice cube.
Melting.
Boiling of water.
Boiling of water is an example for understanding 2 states of matter. Okay, water vapor. And if you take ice cube, yes.
Water can show all the 3 states, sir.
Water exists in all 3 states. Can we simultaneously understand? Can we simultaneously understand all the 3 states? Yes, Harini, Majid, so many students have some melting of ice. Yes, you take ice, put it in a vessel, try to heat it. From the solid, it will convert to liquid. From liquid, it will go to vapor. And see, this another simple experiment is every day. Sorry, we celebrate birthday. Yes, Yes. Around this flame, I have vapor. Yes, because if I keep another candle, it will burn, or I can feel the heat now. Even at this height of about say some 30 centimeter, I'm feeling the heat. So that this is again the thing. And see, now it's what is happening.
Melting of candle wax, sir.
Liquid. This is liquid. Some books will describe there is a fourth state of matter. Plasma is also there near the flame, but that is not correct. For plasma to occur, at least the temperature should be more than 1000 degrees Celsius, which is not possible near this. There is some controversy going on. Fourth state of matter is also present, but don't worry about it. This expand and boiling of ice cube shows that all the three states of matter. Yeah, I'll come for sharing. Because this sharing other thing, my wife is having more experience. She just guides me properly. Just a minute, I'll come. Okay, solid, liquid, gas, and plasma. You have wax vapor, liquid wax, solid wax, the burning, which I demonstrated. Good. Students, instead of raising hands, you can directly unmute and you can answer. Okay. Because I cannot see between three screens, chat screen, my screen, and this one. Okay, and I think people have played with this. What is this?
Fidget spinner.
Fidget spinner, sir.
Very good. Actually, using this fidget spinner, a lot of physics can be understood. A lot of physics concepts can be understood. Okay, right from inertia, torque, angular momentum, Newton's law, friction, pendulum, okay, periscope, many physics concepts can be understood. Just it cost about 32 and so on, depending upon the design, up to some 500 rupees. It's available. Yes, just 30 rupees. This I brought for 10 rupees. This I brought for 30 rupees. Just to show you, everybody will be having this. And see what are the things we can understand. This is spinning. Okay, I just have animated. And we can, I'm going to explain only three concepts based on this. Newton's first law, friction, stroboscopic effect. Okay, Newton's first law, spinning, stroboscopic effect. So what is the thing? See, I'm having this fidget spinner. Okay, now this spinner is at rest. This spinner is at rest. Okay, and I'm just giving a force. What is happening? This fellow keeps on rotating.
Spinning. It is spinning, sir. It is spinning.
Yeah.
Spinning, sir. Rotating.
Yeah, good. Either clockwise or anti-clockwise, both are equal. Horizontal or vertical. Okay. Now see here, this fellow keeps on spinning. Of course, if you have a smartphone, you can find out the frequency of rotation. You can calculate the time period of oscillation and what force you are given. See, another set I am having. What is happening to this after spinning? It is coming to rest. Why this is coming to rest very fast and why this is not coming to rest?
There is less friction.
It has more mass.
Because it has less motion. It has
Of course, this is the thing.
Spinner has more mass, sir.
More mass so that it is not coming to rest. Is it so?
It has less friction.
It has more friction. It has
Yes. Yeah, this has got a density concept will not come here. Both are in air and both are attracted by same gravity. And see, this fellow has got more friction here, so that energy is dissipated. In this case, ball bearings does the job. So the body keeps on spinning.
Rotating.
Yeah, the body continues in a state of rest or of uniform motion unless compelled by an external force to stop it. So this is the Newton's first law. And of course, you are having the friction in this. Almost the friction is reduced, but still there is friction between this fidget spinner and then the surrounding air molecules. Because of that, loses energy. Okay, good. Now see here, preferably if you have this type of spinner, maybe I can show that. I'm not very sure whether you can see that. See, when you see that, can you see that the wheel is likely to spin in clockwise and anti-clockwise?
Yes, sir.
Yes, sir.
Yes,
It is
sir.
becoming slow and
Both clockwise and anti-clockwise.
Yeah, good, good. Whether it is in clockwise rotation or anti-clockwise rotation, you can observe this effect. This is called stroboscopic effect. This effect probably would have seen in wheels of the car. Yes, you'll be sitting, the car wheels will be revolving. It gives an appearance as though it is revolving in anti-clockwise direction. Why? That is called the persistence of vision. Okay, we know that our vision can record an image and give it to the brain. Actually, it's what it is doing. It is just getting light from outside. The light gets scattered and it is interpreted by my brain. Yes, this is spinning. Okay, this is spinning. And for 1/8 of a second, that image will be there. Supposing if I am keeping on superimposing, image gets superimposed and my brain gets confused. So that my brain interprets as though something is revolving in back, something is revolving in the forward direction. This is called stroboscopic effect. Okay, that you can observe with this fidget spinner, or you just look at the ceiling fan, you can observe this. Okay, wheels. Okay, this is called the stroboscopic effect. So with this fidget spinner at just 30 rupees maximum, you can demonstrate so many experiments. And then this fidget spinner, you can take it as a model for the rotation of Earth. No. Rotation of Earth. See, what is the direction in which Earth revolves?
West to east.
West to east.
East to east, sir.
Yeah, excellent answers. What is the direction in which rivers are flowing in the world? Maximum rivers, is it along equator, or is it from north to south or south to north? You studied in your geography.
Yes,
Is it
sir.
along the poles or it is along the equator? Yeah, this is a globe. Okay. About this, my father brought his back. It's no more now. He brought back some 40 years back. Okay, it's a globe. You can see most of the rivers, they are not going along the equator, or it is going along north to south. What is the direction in which rivers are going? North to south or along the equator?
Along the
Along the equator. Along the equator.
Excellent.
Along the equator.
Why not along north to south? Why not along north to south? It is
Because
along the equator.
Because it is
Because of the
shape, sir.
axis.
Yeah, see, actually the axis where what we have is the thing for rotation. It is an imaginary axis. And see, there is an
Excuse me, sir.
Can
it be because of its shape, sir?
Yeah, that's interesting answer from an indirect perspective. I'll explain from your viewpoint. See, it is like this. The earth is revolving now. Earth is revolving. Mass is distributed. Supposing if you vary the distribution of mass, the time period of revolution changes. Okay, that's what some time back in Wuhan city, forget about this COVID virus, this Chinese started building a very big dam. Entire world, other people started obstructing this because there will be redistribution of mass and rotation of Earth gets varied. The time period of rotation of Earth gets varied. So that the entire population, especially scientific population, the world started objecting that. If these rivers are going to run, along the north-south direction, what will happen? Probably, you know that rivers carry a lot of sand in them. Okay, they deposit the sand. In due course of time, what will happen? Mass distribution in the earth takes place. The time period of revolution is affected. That also we can demonstrate with this. Of course, it's a bit difficult. I am having two magnets. I've attached it. I have to do this experiment carefully. Now what is happening is I have redistributed. Okay. I have redistributed. Now when I want to rotate, see, previously my spinner without this mass was spinning very beautifully. Now when the mass is redistributed or when mass is added, time period of oscillation or time period of rotation is affected. A very simple fidget spinner. You can think of doing some project based on this. Okay, good. Let me go to screen share. Students, you understand this concept?
Yes, sir.
Yes,
Yes, sir.
Sir.
Yes,
There
sir.
is any doubt,
Yes,
please
sir.
let me know. If there is any doubt, please let me know. Because teaching for students is very, very difficult for me because you are all well informed and then you are very enthusiastic. If it is advanced learner, it's different. Okay. So I'm trying to do my level best. Yeah, good. This we have done here. Just a minute. Yeah, the concept of fidget spinner, we have done with that. And see here, the stroboscopic effect. Okay, I've explained. Or it is sometimes called wagon wheel effect. We proceed further. Yeah, now my question is, one minute, my question is, you are seeing something here. What are the things you are seeing here?
Iron nail,
Changes.
iron nail candles,
Salt, dusted nails.
Yes. Now see here, let me put it. And this is a burning candle. It's not candle alone. It's a nuclear reaction. In Hiroshima, Nagasaki, during the World War time, the Allied forces dropped a bomb. It gives like a mushroom-like appearance. Okay, bomb, nuclear bomb. Of course, India also detonated 2 times hydrogen bomb. And this is iron nails rusted. That's more important. Iron nails rusted. Okay. And of course, a person after doing some exercise is sweating. This is sugar, which is consumed inside. I cannot show you how it is inside the reaction. I am showing you sugar that is consumed inside, and this is the hot pack. Suppose if you are having body pain, normally in olden days, what our grandmothers will do, they put brick in water or not in water, a brick in stove. Okay. In olden days, we have that coal stove. In that they put it, it will be very hard. They just make a wrap with the some cloth and then keep on the place. Unknowingly they have done that, but there is a science behind that. Okay, nowadays we are having hot pack and hair dryer. These are all the elements which you can produce this effect. Good. What is common among all those things?
So they are chemical and physical changes.
Chemical reaction.
Chemical
reactions.
Yeah, somebody is, yeah. Exothermic change, yes, very good. Because chemical and physical reactions are very broad term. Exothermic change. What is exothermic?
Heat is released in exothermic.
Yes, I'm very happy. Now we would have studied basically exothermic reaction by definition of exothermic reaction. When some chemical reaction is taking place, there is release of heat energy. Yes, there is release of heat energy. That is the most general definition. You have to understand that exothermic reaction is not alone in something like in a test tube experiment alone in the chemistry laboratory. When you light a candle, it is an exothermic reaction in a small scale. When you detonate a nuclear bomb in a large scale, exothermic reaction. Rusting of iron is again an exothermic reaction on a small scale in a long time. See, when you burn a candle, immediately you will get light and heat. When you detonate a nuclear bomb, immediately you'll get. But you can't say that, oh, I'm keeping iron nail in my hand, rusted, I'm feeling heat. No, nobody will believe you. But it is an exothermic reaction. Hope you can appreciate that beauty of chemistry in these things. Okay. The physics, this is a physics reaction giving rise to chemical effect. And when we sweat, heat is given out. That I'm going to explain. Heating of sugar and this hot bath. As you said, it's exothermic reaction. How it is exothermic? How it is exothermic? See here, coal packs to heal an injury. Burning a candle gives out heat. So you call it exothermic reaction. Nuclear reaction gives out heat. So it is an exothermic reaction. Rusting of iron gives rise to iron oxide, in which Fe2O3, that is a chemical formula for iron, iron oxide, which is produced by the reaction of iron with oxygen, Fe with O2. Oxygen is available in plenty in our atmosphere. What is the concentration of oxygen in our atmosphere? What percentage approximately?
21%. 21%, sir.
Very good.
21%, sir.
Yes. If by overnight, if some miracle happens, if God or the nature removes oxygen everywhere except for living beings, the next minute all the buildings will fall down. Okay, all the buildings will fall down. Oxygen is very, very, very important. Okay, whether it is for living being or for non-living being. Whether you are driving a vehicle, oxygen is required for the tires, or breathing, or for plant. Okay, good. Now this person is sweating. Again, this is an example, okay, for an exothermic reaction, because the perspiration evaporates from the skin that releases heat into air. And then the sugar goes into the body, produces a very good chemical reaction by the combination, because sugar is a combination of carbon, oxygen, hydrogen, it gives out heat. That's what we will feel energetic when we take glucose. Okay, immediate energy. That's what the most of the advertisement gives. This is an exothermic reaction. Of course, the cold pack got two bags. One is inner bag, another is outer bag. The inner bag is containing water, while the outer bag contains ionic salt in it. When we press the cold pack on us, what will happen? The water from the inner bag comes in contact with ionic salt and results in those let out heat. As heat is released in the atmosphere. And this is an example for an exothermic reaction. Very good. Probably, see, this once when you understand something exothermic reaction, it is not only for your examination, but in the sense you should expand your thinking and you have to correlate with many things. As I said in the title, connecting bits and pieces to get a grander view. Okay, greater view. Of course, formation of ice crystals is again exothermic reaction. This is very beautifully employed in cold countries. Cold countries, when orange is growing, now see in July in Chennai, you are expecting rain. Okay, June, July, you will be expecting some sparse rain. Why it is raining? Why it is raining? Biologically, mangoes getting ripened or new mangoes are born in tree. Okay, to enhance this reaction, this rain is must. Okay, in our country, in Tamil Nadu. Of course, one of my friends is attending this talk in Himachal Pradesh. They're having a lot of rain, heavy rain. Okay, also in Calcutta, there's a lot of rain. With respect to Tamil Nadu, this is important. When you go to very cold countries where you have orange, this orange is also susceptible to weather. What the farmers will do when frost is coming, what they will do, they will spray water on all the orange trees so that due to the frost when it is coming, in the sense very cold air, the water gets converted into ice. During this process, a lot of heat energy is produced and this heat energy saves the plants. Okay, saves the oranges. So this is used by farmers for a very long time. Very long time. Whenever they started farming oranges, they have understood this concept. They have done that. They are not scientists. Okay, but they have understood this science. Good. And next we'll proceed further. Students, are you comfortable? Are you comfortable with me?
Yes, sir.
Yes, sir.
Thank
sir.
you. Thank you. Thank you. Thank you. Thank you, ma'am. Thank you. Good, good. We'll proceed further. Melting of snow is an endothermic reaction because snow absorbs energy and then melts. Photosynthesis. Photosynthesis, again, it's a endothermic reaction. Of course, there is a lot of higher order physics involved in that. Let us not discuss in this forum now. A lot of quantum mechanics involved in that. In photosynthesis, what is happening? Carbon dioxide molecules combines with water molecules in equal proportion. Okay, they get converted to glucose and oxygen. And here I would like to stress one point. Sometimes in certain WhatsApp I'm getting, some trees and plants are always giving oxygen 24 hours. I don't think these are all true. Okay. Maybe the percentage of oxygen it is releasing, maybe compared to other trees, it will be more. And night times, people are asked not to sleep under trees. The main reason is the reverse reaction takes place. Trees gives out carbon dioxide. And of course, a human being system is such that we can breathe in only oxygen, not carbon dioxide. That's why we feel when we sleep under a tree, especially in village side. Of course, in cities, we don't have much trees. In village side, especially that tamarind tree, which produces a lot of carbon dioxide and heat, when you feel, it is like as though somebody is pressing you. Then immediately they'll say there is a booth, there is some evil sources or nothing like that. Okay, it is because of carbon dioxide. You get that experience. So that people in general not advised to sleep under a tree during night time. Of course, boiling egg, baking egg or baking bread, everything is a endothermic reaction that takes up heat and then gives out. Now you can understand from photosynthesis to melting of ice, okay, from baking, all these things can be explained with one thing, endothermic reaction. Good. Now see here, of course, your chemistry teacher should not stage a fight with me. Okay, I'm just saying in a friendly manner. Malti ma'am, please excuse me for this demonstration. In your chemistry laboratory or in physics laboratory, you will have this arrangement. You have a sensitive thermometer, which can either record the temperature in degrees Celsius or Fahrenheit, preferably digital. I was trying to do, but mine is not going below 90, so that I could not do this experiment. You take water, you take salt, sodium chloride or barium chloride or strontium chloride, anything, any salt. Before mixing, the temperature is 71. Partially mixed, the temperature is 69.3. Now it is completely mixed, temperature is 68.9. From 71, this fellow has come down to 68.9. Okay? From 71, this fellow's temperature, from 71, this fellow's temperature, 1 minute, I'm just taking the laser pointer. This fellow's temperature has progressively come down. Now what is happening in this? Heat is coming down. Yes. So what reaction it is? When heat is taken inside the system, outside appears cool. Exothermic reaction is one which gives out heat. Endothermic reaction is one which takes in heat.
Absorbs the heat.
Yes, yes, yes. It is basically a physical mechanism. You take sodium chloride, mix it in water, heat gets reduced, just evaporated, you get the sodium chloride back. It is a physical mechanism. Of course, you can say it as a chemical mechanism. It belongs to both area now. Okay, good. Now the thing is, I can suggest you a very costly experiment, and you should be very careful in doing that. When you are going to petrol bunk, gasoline bunk to put petrol to your vehicle, ask the shop wallah to put 4 or 5 drops on your hand. Okay, you can feel chill. Very costly experiment. Nowadays, petrol is 101 rupee. I do not know today's rate, maybe 1 or 2. So very costly experiment. If the shop wallah is very generous enough, because your parents will not allow you to touch even 1 drop of petrol. Okay. So when you have a few drops of petrol on your hand, you can feel the chill feeling. Okay. Again, it is taking away heat from your body because petrol is highly volatile. That takes away heat from that. One more interesting point I would like to add in this, of course, I have not included in the slide. What is the fuel used in aeroplanes, which is flying at very high altitudes?
Petrol, sir.
Petrol.
Okay.
Petrol, sir. White diesel.
Somebody said
Petrol,
yes.
sir.
Yeah, somebody said white.
White petrol.
White diesel, sir.
Yeah. What is that white petrol? Will it be white in color?
Excuse me, sir.
No, sir.
Yes.
I can't able to see your screen, sir.
I am sharing, Mark. Please click that because in my mobile also I am seeing my screen. Please check your system. Click on the presentation. Okay.
Yes, sir.
Yeah, please check, Mark. Hurry, please check. Because I would able to see. I am sharing simultaneously my mobile also for checking. Please check, Hurry. Now see, somebody. Okay. See, somebody said white petrol. Actually, it is highly purified kerosene. Highly purified kerosene. Petroleum and diesel is not used in aeroplanes. Okay.
Kerosene, sir.
Kerosene, highly purified kerosene. That is called white petrol. It is transparent. Because sometimes English is a bit confusing for us. They will say dust chicken, but chicken will not have any feather. Okay, and just for fun. Okay, not because English is a very beautiful language. I'm just making fun of the situation. White petrol is transparent, highly purified kerosene. We'll be asking a question, why that is used? See, when you go up, temperature decreases, and you have the troposphere, stratosphere, tropopause, and so on. When you go beyond that, tropopause, at a certain region, the temperature becomes very lower, less than 0, and the aeroplane is subjected to the temperature. Okay, this petroleum gets crystallized. See, when you are flying at an altitude of 30,000 feet, when petroleum gets crystallized, what will happen? It will be a solid, it will not be digested by the aeroplane engines, probably it is catastrophic. So the white petrol is nothing but kerosene. Okay, good. I think this information will be new to you. Okay, good. I have explained. Dissolving a salt is a physical mechanism, but which is endothermic in nature. I have given the reference here. Good. We'll proceed further. Of course, it's a very conventional way. I am just giving an exothermic, endothermic reaction comparison. Anything which absorbs heat, any reaction which absorbs heat. Okay?
Endothermic change.
Endothermic.
Yeah, anything which gives out heat, exothermic. There is a simple way you can remember, a cube or a sphere with arrow marks. Okay? Good. Of course, again, in a simple way, in the way of chemistry. I've taken this from Byju's. Most of the concepts are known, but I'm a bit lazy in drawing diagrams. These diagrams seems to be very good. I've taken from them. Yeah, again, we'll come back. Now you could able to see many things. A coffee cup, very hot coffee. Okay, a very hot coffee. And this is a refrigerator. This is a refrigerator chilling unit. Of course, this I have taken from my house. And this is the AC, split AC. And this is oil being boiled in a pan for frying. And a human heart pumping the blood. Somebody is drawing, please avoid that. Annotation, others please stop. Others please stop. Okay, this is water I'm being boiled in a pan. Okay, water being boiled in a pan, and then air is being heated. Air is being heated. Okay, and this is a conventional transformer. Everybody would have seen this. If you are living in apartments, in your apartments in the entry, you will have a step down transformer. Okay, and this is a motherboard. Sometime in your PC or laptop has gone down, the service engineer will come and show you this. Okay? Good. Next, you see the thing. This is the Earth's mantle. This is rain formation clouds. And this is a star. This is melting of iceberg. Very recently, you read in newspaper, a very large chunk of iceberg is being melted and then it's drifting away. This is black hole. What is common among all those things? Because one concept is covering from your black coffee to black hole. What is the common thing? Can you guess?
Heat.
Yeah,
Heat.
Heat.
Endothermic condensation.
Please let me know. Okay. Any answer coming across your mind, you please let me know.
Endothermic changes.
Endothermic changes, very good. Heat I'm getting. Yeah, endothermic.
Heat
Heat is being
endothermic
exchanged,
changes.
Can be generated all over.
Okay, okay. Any other answers, ma?
Sir,
Okay.
friction.
Friction, very good. Very good.
Heat conversions.
Heat conversion, very good. Yeah, there is a specific name for that. There is a specific name for that heat conversion. In the first slide, what you are seeing, what are the ways in which heat is transferred from one place to another place?
Newton's law. Sir, Newton's law.
Okay, Newton's law, okay.
Convection, conduction.
Very good. Give a very big hand for the student who answered convection. What is the student's name who has given the name convection?
Yashvita.
Yeah, very good, very good, very good. You deserve a special prize. Very good, very good, very good. It is like Egalaiva. Okay, you are like Egalaiva. Fine, you have given the exact answer. I'm happy. Other students have said heat conversion, other thing. It's a good answer, but yours is the most appropriate answer. You deserve prize. See, the thing which is common amongst all those things is convection. Then you can ask me why some 9 diagrams above, why some 5 diagrams below. It's very simple. The diagrams, whatever I am shown in the top layer, they are all forced convection. The diagrams I have shown in the bottom layer is natural convection. See, the convection, the concept, whatever you are studying, either in 5th standard or 6th standard, or sometime in 8th or 9th, 10th standard, that is used to explain the boiling coffee, how milk is going inside, to boiling water, to black hole. A wonderful phenomena. Okay, it is connecting from black coffee to black hole. Same physics. Okay, it is applicable to human. It is applicable to your transformer. I'll explain each and everything. Okay, I'll just explain each and everything. Good. What is convection? See, basically, the concept convection I can define. What to do, how to define. It's a process of transfer of heat in fluids. Fluids in the sense I'm here, it's a generalized term I'm using for both gases and liquids by the actual motion of matter. It involves bulk transfer of portion of the fluid. In conduction, what is happening? Heat energy is carried from one part to another part of the material without any visible motion, of particles. Electron is carrying heat in a metal from one place to another place. You can't see the electron. That is conduction. What is radiation? Transfer of heat energy from one point to another point without any material medium. You need not have any material medium for the transfer of heat. If that process takes place, it's called as radiation. You see the distance between the Earth and Sun, 150 million kilometers. The light rays and heat rays take 8 minutes, 3 seconds to reach from Sun to Earth. Most of the space between Earth and Sun is empty, vacuum. Otherwise, whatever process taking place in Sun, we'll be keeping on hearing. We will never have a sleep. Okay, it will be a noise pollution. So nature has designed such that sound will not be transmitted through vacuum, but light, heat, X-ray, gamma ray, okay, ultraviolet radiation, all these things can pass through vacuum. Good. Two types I said, natural and forced convection. Okay, just a minute. Coffee cup. And every morning, whether you take hot black coffee or coffee with milk, some interesting physics is at work. Fill the cup to the brim. Okay, it should be close to boiling point. Okay, it should be close to boiling point. After that, what you do is you can immediately notice some white dusty areas around the dark lines. These patterns mark the areas where hot coffee is rising to the surface. Hot coffee is rising to the surface and slightly cold coffee is being pulled down by the bottom gravity. And these regions are called convection cells. Okay, good. The next one is convection happens in coffee cup. Okay, convection happens in coffee cup. Just a minute. Convection happens in coffee cup. Okay. By the process of evaporation and gravity. We'll proceed further. Next one. A boiling of oil. You can see some distinct regions, convection cells. These convection cells are visible in the heated oil. Heated cooking oil, the part which is shown in the left side. Heating the oil produces change in index of refraction of the oil. That change in refractive index makes the cell boundaries visible. Circulation patterns form and presumably the wall-like structures will be visible or the boundaries between the circulation patterns. And see, the stars have convection zone. Stars have convection zone. Heat energy is carried from inside the star to outside by convection. There are two things you have to differentiate. Normally, sun is taken as the reference star. Stars whose mass less than sun, stars whose mass more than sun. Sun you can take it like 0. Okay, in number system you can take it like 0, less than that, more than that. High mass stars have convection cores and radiative envelopes. And low mass stars have vice versa, radiative cores and convection envelopes. So whatever convection taking place in your coffee cup, the same mechanism is responsible for carrying heat from the interior of the sun to the surface. Interior of the sun, okay, the core of the sun, the photosphere, outer surface, chromosphere, 14 million degrees Celsius, unimaginable value. The outer surface is around 6,000 degrees Celsius or 6,000 Kelvin. Of course, degrees Celsius and Kelvin is not same, but I can equate it. Just I have to add 273 to that. Yes, participants, some 4 of you raise your hand, please.
It's a question again, sir.
Yeah, please. Harshvardhan, Hema, please.
Sir, question.
Question. Are you going to ask me question or I am asking question with you? Sorry, I'm not clear.
Sir, can you say the question again, sir?
Sorry, I'm not getting you.
Sir, you can explain the high mass stars have that convective core, sir.
Yeah. Very good. See, high mass stars, the sense how heat is transmitted from the center to outside by the means of convection of heat energy. Okay. Ma'am, organizing ma'am, you can give admit of students, ma'am, when they are coming in between. I think I'm switching between 2 windows.
Okay, sir.
Okay, because they are keeping on coming. Okay, fine, because there's probably some network issue, other thing.
Yes, sir.
You please give that admit for them. Okay.
Yes, sir.
Yeah, fine. So low mass stars, in the sense, the core is radiative in nature and envelope which is covering that is convective. Okay. The outer envelope. That's the main difference. Let us not go very deep into that, what type of reaction is going to take place, what are the mass of those stars and other thing. Maybe some other occasion, we will have a specific discussion on this convection alone. I hope I have answered your question. This is a convection. Yes. And students, meanwhile, one thing, at the end of the lecture, I leave with you my mail ID and phone number. At any time, if you have doubt, always please feel free, feel comfortable to mail me or just message me and call me. If I am in class or meeting, I will not take your call. Otherwise, I am always very happy to interact with you, discuss with you. Okay, no boundaries. You can always count on, even if you get doubt after some time. Okay, even if you get doubt after some time, even after 5 years, I'm very happy to answer. I will explain what doubt I got when I got the answer. See, this is convection cells in the sun. Okay, you can appreciate the convection cells you are seeing in the oil. Can you see that? Okay.
Yes, sir.
Yeah, the same thing.
Yes,
madam
sir.
has given instruction to me. Instruction in the sense, basic thing. All the students are in English medium. You have to keep your language English. But we are in Tamil Nadu. One poem or anecdotal thing I'd like to say: Andame pindam, pindame andam. Whatever present in the human body, present in the universe. Okay, pindame andam. Andame pindam, what are present in the universe, present in the human body, vice versa. Now see, very beautiful thing, the convective cells in oil, the convective cells in sun, in a large scale. For example, in the sun's convection zone, outermost layer of the interior, which extends to a depth of, say, about unit sense 100,000, 10,000 lakh, 2 lakh kilometers up to the visible surface. This means that energy is transferred through convection in this region. Okay. Very recently, scientists have speculated convection tubes for transfer of heat energy. Okay, convection tubes. The lines in the heated cooking oil are called by the name, Rayleigh-Bénard cells. Okay, Rayleigh-Bénard cells, the name of scientists who have done research on that. The structures on the surface of the sun are the boundaries of solar granules. Both arise from the same phenomena, convection. See, a very beautiful thing, a simple physics explains so many concepts. Okay, I just made a comparison. Water boiling. Actually, when water is heated, before heating, the entire density of the water is the same. As you start heating, the molecules in the bottommost gains kinetic energy, expand. They go up. The heavier water in the sense, the water which is more dense, cold water, not heavy water, heavier the water. The cold water comes down. The process goes on. Actually, we expect to go in circles, but due to turbulence, normally you will not expect this exact diagram. Okay. Here both gravity, buoyancy, density comes into effect, and water undergoes a cyclic process. Hot water goes up, cold water comes down. And it is very interesting. If you want to boil water in zero gravity, you can very beautifully observe convection will not take place. Okay? Convection will not take place. Maybe some of you might plan for going to other planets, because in due course of time, people started advancing. Okay. In spaces, we started going. You can perform these sort of experiments and then have a taste for that. Now, this is a refrigerator, of course, typical refrigerator in my house. Why the chilling unit is kept at the top? Why not at the bottom?
So because of
Because
dry,
of
sir.
the small
Dry is
stars are
more
more
than
denser
the
than the
cold water,
hot
it can
thing,
heat
ma'am.
up the ice, sir.
Sorry, ma'am, please again.
Because it is cold.
Because of the
Okay, good. 1 minute, somebody is asking for admission. See, again, the same thing. Split AC is kept at the top. The issue is gravity plays a vital role here. Again, whatever we have seen in the boiling of water, there warm air rises, and then cold air sits down. Because cold air, the density is more than the warm air. Here, this is going to produce a cold air, the density is more, it has to descend down. On the other hand, if I keep a chilling unit at the bottom, probably against gravity it will not rise, so that my purpose is not solved. Of course, in another 5 to 10 years, you will not have a refrigerator of this type, another thing. You are going to have small packet size refrigerator. In the sense you have a bag, what will happen? You just have a USB, put in that, program it and then leave it. You need not go to the opposite house mommy and then say that keep our milk and these things for 5 days and from native will come. No, not like that. You just give the USB, say to the mommy, put it in your house in USB, keep these fruits. Okay, selectively designed products are coming up. This refrigerator will not occupy this much space in your wall itself. You can hang the refrigerators. And another exactly 10 years, maybe 2021 and 2031, if I'm coming to your school, and if you are coming back, you can explain to me that that is the case. Okay, good. I think let me go. Convection. And then this type of house we have not experienced in Chennai at least. Okay. This type of house we have not experienced in Chennai at least. The thing is, maybe in very cold places like in India, we have Kulu Manali and many places in north where you get very cold. In those places, we want to keep the house warm. You have gravity furnace, nothing a furnace in which you put these materials, burn it. Okay, exhaust gas will go out. What will happen? This hot air rises, goes, and then this convection process keeps on going. Okay, this is a convective loop transfer. Fine, we proceed further. See, cumulus and cumuloluminous clouds. These are two different types of clouds that form because water vapor rises. Dust molecules are present in air. They nucleate on it, water nucleate on it, and then this water vapor goes up, forms a cloud. Okay, when cold breeze blows on it, it comes out as rain. Of course, May 31st, I've given a talk on lightning exclusively. I've discussed so much about this. The thing is, the formation of clouds is an example for convection. Okay, of course, we had very great mathematicians in India like Bhaskaracharya, Varahamihiri, and Ramanujam. This Bhaskaracharya, the mathematician, is so great. He just observe the clouds and then he will predict whether earthquake will come to that place or not. Because before the earthquake is occurring, water in that area evaporates, it seems to be, and it forms some different shaped clouds. From that, he could able to predict whether earthquake will come at that place or not. It will be quite interesting when you go to the top of your house, okay, top floor, and then watch the clouds, what shapes it are, how it is moving, okay, what color it is having, why one part of sky is black in color, another part not black, gray, another part is white. The thing which is towards sun will be white, and the cloud which is opposite to the sun's face, sun's direction will be gray in color, all those scattering. So many wonderful phenomena you can understand. I'm sorry. We proceed. Movement of iceberg. See the iceberg reduction thickness. Yes, Pooja. Yes, Pooja. Pooja, raise your hand, please.
Sir?
Yeah, you raised your hand. Any doubt?
No, sir, wrongly raised.
No problem. No problem. Not an issue. See, as warm air blows over the ice, there is an increase in temperature, it breaks. And this is called global warming. And we should be clear in reducing this global warming. Okay? How in the sense, so see, when you're watching your mobile for 8 hours, reduce to 4 hours. When you're using your television for 4 hours, reduce to 4 hours. Okay, unnecessarily don't loiter around using petrol. You can reduce it. Okay, those things you can reduce the heat and carbon content. If you are really concerned about ourselves. Good, it's a request. And the heat sink. Again, the heat sinks are used to carry out heat. The heat sinks are used to carry out heat by the process of convection. Yes, Ibrahim, you raise your hand, please. Okay, good proceed further. Heart pumps blood. Very wonderful motor. Okay, wonderful organ in our body, which forms when the baby is formed in the mother's womb itself, and it pumps at least 5 liters per minute. And see the motor capacity. And the heat is carried away by the skin by the process of convection and conduction. Okay, from the surface tissues, blood circulation is higher, heat transfer is mainly convective. See, one single process, convection, is giving so much. Blood circulation is by post-convection. Motion of, yes, Saranishri.
Sir, sir, you said icebergs are convection, no, sir. Why did iceberg is fall on water? It doesn't melt, sir.
Yeah, very beautiful question. Iceberg falling on water doesn't melt. See, the question is, ice is a poor conductor of heat. Okay, ice is a poor conductor of heat. Once when ice falls on water, what is happening? Because of less density, it floats. Because of less density, it floats. And it is a bad conductor of heat. It will not conduct heat that much from the water. Okay. That's why, yes, water will not freeze from the bottom of the lake. It freezes only from the top. Very good question you have asked. Okay. So that all the marine living beings are spared. If ice is going to form from bottom, alas, within a year we will not have any fish, other things in the ocean. Good. We proceed further. See, the most of the mantle of the earth is again by natural convection. Okay. See the movement of earth's solid silicate mantle resulted from convection current. This carries heat from interior to the plant surface. Actually, this is caused by 3 fundamental processes: heat loss from the core, internal heating from radioactive decay, cooling above. Because of that, it causes movement of lithospheric plates, surface volcanic activity, magmatism, earthquakes. All these processes are byproducts of convection. Okay. Transformer. You'll be wondering why this transformer is having wings like this. See, actually the process is like this. Transformer, most of the transformer used in India are oil cooled, air cooled transformer. There will be transformer oil inside. Once when transformer is going to transfer power, whether it is a step up transformer or step down transformer, heat is produced. You can understand this very easily. You need not go to transformer. You take your mobile charger. After charging for half an hour, you touch the mobile charger to be hot. Okay, because energy is transferred from one place to another place. The transfer is not 100% efficient. Certain amount of energy is lost in the form of heat. Okay, I square RT. One form of heating, I square RT. Amount of current flowing through into resistance into time. Square of current into resistance into time. See, naturally, the hot air rises, comes out, gets cooled by the process of radiation. Harshvardhan, do you have any doubt?
Sir, you said that for an iceberg is as a very less temperature, sir. But what about it carbon dioxide ice, sir?
That's an interesting question. I don't know the answer immediately. I will let you know. Okay, I'll make a note of it. I'll send the answer. Ice with carbon dioxide. Okay, I'll send the answer to our madam. Okay. You can get it from me. Yes, another two participants raise the hand. Yes. Yes.
Sir, for asking doubts, sir.
Yeah, please, please.
Sir, can you again explain about the natural convection? Sorry, sir, some network issue.
Fine. Natural convection is taking place in Earth's mantle. Okay. And carrying out heat from interior of the Earth to outside. It is taking place. It is taking place in stars. Okay. Stars whose mass heavier than sun and less than sun. Okay. And it is taking place natural convection in melting of iceberg. Okay. And in lastly, it is speculated in black holes. Okay, that's called natural convection. Whatever which is not made by man, when convection occurs, it is natural convection. Okay, ma? Transformer is made by man, it is forced convection. Okay? Blood will not come as such from the human body. Heart has to pump by the human body. It is forced convection. Good. See, this oil comes out from the top, gets cooled, comes down. A transformer oil is natural cool system. We can't open the transformer each and every time because it's very costly. Okay, good. Lastly, about convection, accretion disk of black holes. Okay, of course, for all the reference I've given at the last. This is an unusual example, little bit higher level, but anyhow, some of you after +2 you will be joining your integrated MSc and doing your PhD side by side. After that, you can get an idea about black hole. The convective motions in black holes are developed by the dissipation of intense gravitational rotational energies in the accretion flows. This is the rough picture of black hole they have given. Okay, it's a imaginary. It will be like that. Okay, and can you identify this person? He is not a film actor. Okay.
Stephen Hawking, sir.
You are very near, but he is not so. Stephen Hawking is a person with spectacles. He sits in the chair. No. Anyway, good guess. Anyway, let me, without wasting time. He's called Professor Dr. Sir Roger Penrose, the person who said yes, black holes are existing. Derivation, high order mathematics derivation using tensors, he has done that. Very recently was awarded Nobel Prize. So that the process of convection is wonderful. It's a hero. It is connecting from your black coffee till your black hole. Okay. Organizing, madam.
Sir,
Yes, sir.
Can I take some more time?
Yes, sir. Yes, sir. You can take, sir.
Yes, ma'am. I just have some water on the net.
Yes, sir.
Because it's very interesting. Students are asking a lot of questions, very encouraging for me.
Yeah, okay, sir. Thank you, sir.
You are very good students. Okay, fine. We'll come to the concept. If hot air rises, why it is not so cold at the top of a mountain?
Devapriya, can I say, sir?
Sorry, ma?
Devapriya, shall I answer this, sir?
Yes, please.
Sir, as father, we are going up from the Earth's surface, sir. The atmosphere gets thinner and the total heat content of a system is directly related to the amount of matter present, sir. So
Very
how
good,
much
very
heat
good.
is also increasing also, the top of the mountain doesn't melt, sir.
Okay, very good answer. Very good answer, Devapriya. Very good answer.
Thank you,
Anyway, for the benefit of others, I will explain. Okay, good. Address me as Devashankar. Fine, not an issue. I'm not very conventional. Okay, I'm at college level. I'm still young like you. Okay, mentally, I would like to be at your level and then answer. Good. See, it is like that. As said by Priya, this gives the altitude, height, and pressure in millibar. Okay, at a zero height, near the surface of Earth, it's 1 bar. As you go up, it is reducing. Okay, that's why it is very dangerous to jump from enormous height without oxygen and also go inside the water below 1 kilometer without oxygen. And both are very dangerous. See, it is like this. There's a drop in pressure. Gravity is maximum at sea level and it decreases when we move up. Above mountain, the gravity decreases, so the atmospheric pressure decreases. A decrease in pressure decreases temperature. Okay. Of course, PV equal to nRT. That is the equation. When the pressure increases, more number of molecules are contained in the space. As Devapriya said, every particle possesses certain amount of heat energy. When the number is more, heat energy is more. When the number is less, heat energy is less. So when there is decrease in pressure, less number of molecules, temperature goes down. Okay. Of course, the same thing as we go beyond a particular height, again temperature increases. And the main culprit here is our water vapor. Okay, that is a greenhouse gas that is present at least 36 to 70% in atmosphere. Normally in Chennai, we feel very hot. Okay, also in Vellore, 4 or 5 times I came. Okay, it's very hot place because of mountains, small mountains and less greenery. In Chennai, though mountains are not there, it is near seashore and the water vapor in atmosphere is very high, so that the perspiration rate is more and we feel very hot. And this water vapor absorbs heat from the sun. Okay. And at the ground level, this is the case. At higher altitude, water vapor is less, that condense due to decrease in pressure, forms a mist. And water vapor present at the top of mountain is less, so there is less absorption of heat from the sun. Okay, so that there is decrease in temperature, or which prevents rise in temperature. That's the physical process. Good. Now, what is common among all those things? I'm sorry, I'm showing many things common to you. What is common amongst all those things?
Convection, sir.
No.
Heating.
Convection, convection, that story you have completed, ma?
Heating, sir.
Very good.
Science, sir.
Wow, very broad answer, very broad answer. Very broad answer. See, this is toothpaste. Everybody would have used your house. Everybody would have used your house.
Yes, sir.
Yes, sir.
Good. Let me come back. This is the toothpaste. Don't worry about brand, other thing. I'm not promoting any brand. I'm just keeping it. Nothing is coming out. Am I correct?
Yes, sir. Yes, sir.
I have brushed my tooth. I'm not going. When I apply pressure, what will happen? It will come. But when I stop applying pressure, it will stop. Am I correct?
Yes, sir. Yes, sir.
Good. So this material is a different one. And then this is honey. See? It is very pure honey from Kanyakumari. And it is taking some time to descend down. We say it is more viscous. Okay. Similarly, this is coconut oil.
Yes.
Taking a little bit less time than honey. Okay. And this one is ketchup. We know that. Normally, what we'll do, we invert like this. Of course, I've kept in refrigerator, so it's flowing down. We'll tap it on the head. Am I correct? Am I correct?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Sir. Yes.
Yeah. Yes. Very, very important observations. And then see, and this is water. See how freely it's flowing. Not like honey. It is not making a much fuss. Okay, water, alcohol, petroleum, kerosene, diesel. This all flows very easily. Okay. And this fellow is a shampoo. And of course, when I open, this fellow will come down. Okay. But this is different from water. Now the concept, what I would like to drive is, let me come for sharing. What I would like to drive is,
Sir, fluid, sir.
Density.
Fluid, sir.
Density, sir.
All liquids are different densities, sir.
Yes. Different density, mainly viscosity. Mainly viscosity. Let me put it. Chocolate, melted chocolate, human nerve, paint, mantle of earth, cheese, sauce, face creams, and quicksand. These are all printing inks, sand castles, in the sense wet sand, sand slurry, all slurries, mayonnaise. Mayonnaise actually a very good output of nanotechnology. Okay, nobody would have thought from that angle. These scientists thought, why can't we mix oil with water? Normally, oil is not miscible with water. They made it. You are getting mayonnaise, veg as well as non-veg. It is an output of nano product and your blood. Okay, blood, and then rubber solution. The one thing which is common amongst all these things are whether it is a Newtonian fluid or a non-Newtonian fluid, like vegetarian, non-vegetarian. Liquids which obey the Newtonian fluid, okay, viscosity is constant with the shear rate, with the flowing, depends on temperature. They are called Newtonian fluid. They are very happy. Newton is very happy. Okay, because liquids like water, kerosene, and Dettol, phenol, alcohol, these are all called Newtonian fluids. Okay, pure liquid in single phase. Of course, we are not much interested in those liquids. Much of the output is coming from non-Newtonian fluids. Some fluids, man-made as well as natural, does not obey the Newtonian behavior. Okay, they don't follow the regular laws of physics. Okay, they don't follow the regular laws of physics. And these properties of these fluids change because of pressure, time, or temperature. Okay? Okay. For example, some non-Newtonian fluids become rock solid once when you apply pressure. Some will become thin when you apply pressure. Very interesting, no? When you start applying pressure, they become thick. Some fluids will be thick. Once when you apply pressure, to become thin. Okay? Contradictory behavior. That same thing is used. Say in I shown the ketchup bottle now. It is thick, but once when I apply pressure, it is becoming thin. And you are preparing bread and the duff. Once when you keep on stirring, it will become very thick. Okay. Okay. Where it is used in physics?
Yes.
What is the use of that? Okay. Just a minute. Somebody is at the gate. I'll come. Okay. See, of course, don't worry about all these classifications. Okay. Based upon the behavior, it is called pseudoplastic or shear thinning, juice, concentrates, pures, emulsions, diluent, shear thickening. As you apply force, the liquid viscosity thickens, liquid chocolate, and plastics, viscoelastic material. Human nerve is a viscoelastic material, thixotropic, rheopectic. Don't worry about all these definitions. Okay, just for our completion purpose, I've given this. The thing is, this is how you can classify. Ashwardhan, yes, please.
Sir, it is the liquid viscosity things you said, sir. Then liquid is little compressible only, no, sir. How it will be thin, sir?
Yeah, very good question. Liquid is little compressible only. These liquids are not pure liquids. Okay. Based upon the external pressure you are applying, the molecular arrangement undergoes change. It appears and it changes its behavior. Okay. The polymers in them gets aligned. Okay. They start flowing. One over the other. It's becoming thin or thick. Liquids are not compressible. Especially Newtonian liquids are not compressible. Whatever great deal you do, it is not compressible. But these liquids behave in a different way. That's why I said they are non-Newtonian fluids. I'm introducing a new concept to you. Probably you would not have heard this word, non-Newtonian fluid. Okay, ma?
Yes, sir.
Yes, sir.
Have I made your
Yes, sir.
very good. Very happy you understood a term which others will be knowing at MSc level, non-Newtonian fluids. I just given an example. Okay, I just given an example. Sorry, not in the table. Thixotropic, rheopectic, shear thinning, dilatant, or shear thickening. Don't worry about all these terms. Don't worry about all these terms. Okay, you can do some wonderful experiments you are doing in your house. Okay, take the tomato ketchup bottle, tap it, and see that how it is flowing. Take honey. You can do an experiment. Take 50 ml of honey and keep it at 30 degree. How it is flowing, how much time it's taking. Take castor oil. Try to do those things. Try to have a hands-on experience. Okay, hands-on experience. Good. Meanwhile, excuse me, I'm going to have a coffee also side by side. Grease. Grease is a non-Newtonian fluid. The red color material, whatever you'll be using, grease. Okay, once when you use that, okay, once when you use that, the lifetime of sealed material is increased. Probably in the near future, everybody is going to use electric car. This type of technical advancement is a must. Anybody having this case like that for your mobile phone?
Yes, sir. Yes, sir.
Have you ever thought?
Yes, sir, I am having.
Yes. Have you ever thought why that material is like that? What is the use of that material? Accidentally, when you drop your mobile phone also, what will happen? That material
It protects us.
and absorbs the impact. Okay, mainly they're used in iPhone cases. So be happy that you are using a non-Newtonian fluid. Okay, I don't have an iPhone. Okay, and you know what is the material which is used as a base for constructing Taj Mahal? When we construct house right now, we are using pillar, columns, and other things.
Marbles.
No.
Cement.
Marbles.
Cement and bricks, sir.
Base material. On which base it is started constructing Taj Mahal?
Steel rods, sir.
Limestone.
Okay, very good. Let me answer. It is based on wood. It is based on wood. Okay. The base material for them is wood. Once when you go to Taj Mahal, you should not see the beauty of Taj Mahal alone. You should see the interior construction. Okay. Any temple, any mosque, any church you go and see how it is constructed, not the modern day temples and other things. Okay. And in places like where you get earthquakes very often, like Japan, you can have these materials. Okay. Viscoelastic material, they can absorb the heat. You can have a body suit which is flexible to permit body movements by the wearer, but fast enough to stop from weaponry. Because nowadays shooting and killing with sword and knife is becoming more. Okay, we have to design shirts. We have to design shirts so that it can withstand this. At the same time, it should be comfortable to us. Okay, good. See here. Shear thickening fluids are found in our body. Yes, the synovial fluid that coats the joints in our knees and elbows is shear thickening. Usually the fluid is not very viscous. Okay, so as to allow us free movement of joints. You can move your joints very freely. But if you bump your knee or elbow on a sharp corner of a table, immediately this synovial fluid, your friend comes to the rescue, instantly become more viscous and cushioning your joint from the pain. Okay, this is very interesting. Shear thickening, how it is happening. Shear thinning, how it is happening. Somebody asked, sir, can a fluid is not compressible, how it is happening? Shear thickening, shear thinning, how the polymer molecules gets rearranged based upon the applied force. Okay, next time when you hit any place, thank your synovial fluid, non-Newtonian fluid. And some times back, we are using only Kevlar or heavy metals to stop ourselves, to take care of ourselves from the bullets. We, in the sense, our armed force people. Nowadays, this shear shear thickening materials are used to absorb the pressure, okay, of bullet. Bullet is carrying a lot of energy. That energy will be dissipated and will be sick. This you can do it very easily. You take water, churn it. The வீட்ல மத்து இருக்குல்ல அதை வச்சு churn பண்ணுங்க. Churn it, water will never rise. But any non-Newtonian fluid will try to climb. This is called Weissenberg effect. And once when you stop churning, it will come back to the original state. There's some fun you can have with your house. Okay. And now next thing is we'll come to other concept. Whatever you hear, whatever you see is not genuine. You have to analyze. Kannal kaanbadum poi, kaadal ketbadum poi, thira visaripade mai. What is the use of that? See, now I am talking to you. Whatever sound you are hearing is different from whatever sound I am hearing. Okay. I hope I'm not confusing you. You record and hear your voice will be different. Why? The person who is hearing this lady's voice will hear differently, and the lady who is hearing her voice will hear differently. In the sense, there are two ways in which sound is transmitted. One is airborne sound, another is structure-borne sound. For this person, it is airborne. Whatever she speaks, that sound energy is transmitted to his eardrum by air. But for this lady, sound energy is transmitted by air as well as through her jaw bones. Okay, so that they superimpose on each other, and this lady hears her voice differently, and the same lady's voice will be heard by this person differently. Probably, if you talk to your mobile, record it and then rehear it, that will be different one than you are talking in open air. You please try this after your after this lecture when you're free time. Okay, so kaadal ketpadum poi, the same thing, the same concept. The noise level, when do you worry about your mother who is cooking in kitchen? The domestic generator we are using, it produces sound of 80 to 85 decibel. Vacuum cleaner you are using in a house produces around 87 decibel. Pressure cooker releases sound at 83 decibel, which is beyond the audible limit. Okay, maximum is 45 decibel. Maximum is 45 decibel prescribed by World Health Organization. So that as you grow up, think of designing some machines which can produce very, very less noise. The washing machine in our house, whatever you're using, is noise free. But of course, I have to shell another 5,000 rupees for that. Old washing machine, when it washes, the entire street knows that it's washing. Okay, before 10 years. Okay, so that as growing scientists, you can think of reducing sound. Vacuum cleaner, which does not produce any sound or minimum sound. Now I'm coming to the concept of Doppler effect. Of course, this I've given equation, all those things, don't worry about it. The main thing is the apparent change in frequency due to the relative motion between the source and the observer. See, when you are at rest, the thing which is producing sound is at rest, you will hear the frequency, say nu. Supposing when the source is approaching towards you, you will hear a different frequency. When the source is moving away from you, you will hear a different frequency. Probably you can have an experience of this when you are in railway station, waiting to receive someone or waiting to board a train. When the train is entering into the station, when it is giving a horn, you will hear a different frequency. When the train is moving away from you, you will hear a different frequency. That is called Doppler effect. Suppose you are standing in a road when ambulance is going, the siren is given. When it's approaching you, you will hear more sound, more frequency. Okay, and when it goes away from you, less frequency. Where it is used. Say, this effect was discovered by the scientist Christian Doppler some 200 to 250 years back. This is a baby inside mother's womb. probably most of your mothers will be having this recording. See, the ultrasonic waves goes inside and the baby's heart is pumping blood. It goes up and comes down. So that ultrasonic waves are repeatedly reflected. Okay, when the heart is going in, going out, going in, going out. In a rhythmic way, there is change in frequency. There is software the doctors use to understand this image. The software converts it into image. From that, you can understand whether the baby health is normal or not. Our heart is normal or not. All those things, non-invasive methods, you can understand from this Doppler effect. Very simple effect. The same Doppler effect can be used to find whether the oil flow in a tube is normal, whether the gas flow in a tube is normal. Same Doppler effect. It's applicable to many situations. Okay. Good. Anybody can guess this actor? Anybody can guess this actor?
Sir, Anil Kumar, sir. Anil Kumar, sir.
Yeah, very good, very good, very good, very good. Very good, thank you.
Anil Kapoor, sir. Anil Kapoor.
Okay. Anyhow, students started answering 50% correct, so I said thank you. Okay. Normally, I don't watch movies normally, but this movie was very interesting for me, though I have studied physics. I'll explain, though I have studied physics. This person is becoming invisible. Okay, this actress Sridevi, of course, is no more. And of course, it is a grand movie, blockbuster movie. It has earned millions. It has earned millions. Okay, so many awards. Only for movie you can watch this. If you study physics, if you are very clear about physics, probably you may not say this movie is correct. Why? Because this person will become invisible and it does a lot of good things. That's our story. Can an invisible person see another person? That's the question. The thing is, can an invisible person see another person anything?
Yes, sir.
No. Because light has to undergo refraction so that it enters from air to our eye. Okay? Light has to undergo refraction. See, the light is coming. See my eyes? My retina, it has to undergo refraction. There is change in refractive index. Air is having refractive index 1. My retina is having some other refractive index, say 1.4. So it refracts, goes inside my brain, and my brain process, I am seeing Harshvardhan, I am seeing Blessy, I am seeing Pragadesh, I am seeing Saranya. Okay, I am seeing the photo, I am seeing the wall. If light is not undergoing diffraction in my cones, I can't see anything. I am invisible, other person is also invisible. This is the basic physics. Okay, let's go for subject presentation. This is the basic physics. So that if you understand this physics, probably this movie is a fun. This movie is just a fun. Anybody who is invisible to others, others also invisible to him. Okay, that's what the author H.G. Wells, he has basically written a novel, Invisible Man. He admitted saying that it is not possible. Maybe scientific fun we can have. Okay. By the same token, probably these war movies you have seen, okay, lightsaber duel, they'll be using laser light to fight. We'll also be whistling, clapping, howling, or after seeing this movie, we are much excited. Actually, this is also not possible, okay? Because lightsabers will not repel each other, because no two light beams repel each other. To take two torch lights, okay, cross those lights, they go as such, nothing has happened. Okay, only at very high intensities it will take place, which is not possible with our modern technology. So that fighting with laser blades, laser sabers, it's not possible. Okay, just for movie you can enjoy. And also Star Trek. I used to watch this serial when I was doing my 10th standard, 1985. I was very crazy about this. Okay, Cosmos, Carl Sagan's Cosmos, very interesting movies. Okay, Star Trek, all those things. In all these things, they'll be using laser to melt down, laser to blast. Okay, they'll just melt away, vaporize. But it is not possible using these spaces like blasters. faces also not possible. Okay, don't get carried away by the movies. I'm not against movies. Sometimes we have to exercise our brain and we have to use the physics to understand whether such concepts is possible or not, because you should not be carried much away by the movies. Okay, just for entertainment, 3 hours. Okay, once in a while we can see movies once in a week. That's good for us also. We can think in a different way. So the next concept, whatever we are going to discuss is, how many of us have seen colored bangles, or how many of us are wearing that? Because nowadays, most of the women are not wearing glass bangles or not wearing bangles at all. Colored bangles you have seen?
Yes, sir.
Yes, sir. Yes.
Yes, yes. Colored bangles I have also seen. Blue, green, yellow, red, and so on. Take some colored bangles, have gloves, take a mortar and pestle, powder it, blue color bangle, or brown color or yellow color. What color it will appear? Will it be blue in color after smashing into pieces? Fine powder?
Transparent
No,
white.
sir.
It appears white. It appears white. Whatever be the parent color, whether it's a blue bangle or yellow bangle or brown bangle, everything appears to be white. Is it color is lost? Is color is lost? No, color is not lost. Okay, because once when you powder it, light is reflected from it in all the angles, they superimpose. Already we know that when red, blue, green colors, fundamental colors join, it will become white. Similarly, sunlight is white in color. It is getting scattered from these particles at different angles. After scattering, at different angles emerge. Because of the randomness, they appears to be white in color. Okay, by the same reason, when you see Niagara waterfalls or when you see any waterfalls in India, it appears to be white. The beauty of the thing is it is not white in color. It is due to selective scattering. Okay, and a beautiful thing here you want to understand is this is a very good example for dissolved oxygen. Normally scientists or your biologists will be saying, okay, dissolved oxygen is more important. If the dissolved oxygen is less, marine species will not survive. How to understand oxygen is present? See, when water is coming from high altitude, it is more, what to say, turbid. Turbid in the sense, more chaotic. Okay, more chaotic, not orderly coming down. If it is more chaotic, it is more turbulent, exact word I have to use. I forgot that word, sorry for that. More turbulent, it will absorb water from the atmosphere. Okay, oxygen is absorbed, oxygen gas is absorbed into the water. Okay, water with oxygen gas molecules pocket present. So now light is reflected both from water as well as oxygen, hence we get the white color. This is what the poet has written. Vairathai urukki ootinor pol oru thotram, as though diamond is melt and flow like that, it gives an appearance. Okay, it's a very good example for specula, that is scattering of light and then explaining dissolved oxygen. Also, this is an example for conversion of kinetic energy into potential energy. And water temperature at the top and water temperature at the bottom will not be the same, because water is doing some work in descending down. So its temperature, when it comes down, it will be slightly, marginally, okay, some 0.01 degrees Celsius higher than the water at the top. Now, this is the general question. Many of your parents, in the sense, many of your fathers or grandfather will have a shave, and after shave, it appears the skin is green in color. Of course, I am black. I can't claim that I have seen that. Why that green tint is appearing? Okay, why that green tint is appearing after shaving? See this person, he had a shave, Can you see the green tint?
Yes, sir.
Yes, sir.
So,
We can see, sir.
I'm sharing, ma.
Yes, sir. Can see.
Yes, sir.
Yes, sir.
sir.
Ah, okay, good. I see the son and father pair. Good. Of course, I asked now, even after 5 years, if you get doubt, you ask with me. When I was doing my first PSC, at that time I had a shave. It was giving a green tint to me. I said to my mother, it is giving a green tint. As she said, there's maybe some problem in your skin, you go consult a doctor. I didn't have any skin problem. I asked with my physics teacher in college, physics professor, sir, after shave, I had a green tint. Why is that? See, at the time in college, how we will be? The sir got angry and then he said, get out of my class. I said, why? Are you saying to everybody that you had a shave? This is not the way you have to behave in the class. Sir, I said, I'm having a doubt. I'm having a green tint. Why that is happening? Because at that time, optics was taught for us. I was standing for a week outside. This I was sharing with my students. Of course, I got the answer later. This experience I was sharing with my students when I was working in a college, engineering students. After a month's time, one student came and said, sir, based on this concept, I have proposed an experiment to Intel, and then they gave me some price, so many dollars. This is for you. I said, this is your understanding. This price goes to you. He made some nano mirrors. He want to reflect the signal. All those things he have proposed. See, the concept behind this is when he had a shave, there are nano size hair is there, hair follicles is black in color, his skin is white in color. Reflection is taking place from black and white, okay, or the skin color, the yellowish color and black. The reflection at different angles, it appears to give a green tint. If the person is black, probably you can't see the green tint. So here also optics plays a vital role. Okay, the color of skin again is due to porosity. Of course, this experiment is done by me. This is a green laser which I'm having, and this is a tray which I'm having. Now what I have done is I have passed this green laser through pure water taken from filter. It is having some particles dissolved in it so that the path of beam is seen, scattering. Now this is through a solution containing salt and sugar mixed so that scattering is more. Okay, this I have done 2 weeks ago. And this is through a prism where you can see only the entry point and exit point. You can't see the light being scattered here. Okay, if there is no particle scattering light, you can't see the path of light. That's what I have said in Star Wars movies, you can't see the laser. And this is again the same. Okay, it's self-explanatory. Now I'm just going to show you YouTube. Just observe that whether you could able to see that. One minute, I'll just play the YouTube. Yeah, I'm just going to play it, just observe. That is a blue laser passing through a prism. This is the entry point, this is the exit point. Inside it is becoming green. Can you see? It's a prism, entry point of laser, exit point of laser. Inside it is becoming green. This is for about 1 minute. Entry point blue, exit point blue, inside it is green. At the end, I will explain why it is green inside. Can you see that, students?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. It's visible. It's like green.
Great. I'm stopping here and then I'll come back. I'll come back and then just a minute, new share. This is a red laser passing. Okay. Of course, I recorded in the college so that background noise will be there. It's a red laser passing. You can see the entry and exit point alone. Just the corner of the prism. The corner of the prism, I'll show you what prism I've used. Okay. Light passing through the prism, transparent prism, it is not seen. The first case, green light was passing, blue light was passing, blue, violet. That is appearing green. The second case, yeah, fine. The second case, what is happening? The second case, red light is passing and I can't see the red light passing inside. Okay. I can't see the red light passing inside. Why? See, the basic reason behind that is, of course, this I have recorded some 7 years back. The physics teacher or science teacher taught you what they taught. When light travels from one medium to another medium, there is change in wavelength. There is change in speed. The frequency remains same because energy is conserved. Yes. How many of us have understood?
Yes,
How many of us done the experiment?
Yes, sir. Understand, sir. Yes, sir.
What is changing? What is changing? Change in color. What I have done? I have focused a blue laser inside glass. The refractive index is different. Medium is different. It has turned to blue. It has turned to green. When it exits, again the wavelength has decreased and it has come as blue. The blue laser, when it is passing through prism, has become green. When it is coming out, again it has become blue. Energy is conserved. A red laser, on the other hand, would have converted into infrared or no scattering would have taken place. This I have uploaded some 7 years back. I went as external to a college. It was very boring. They had a dark room. At the time, I had a blue laser. I do not know what happened to the laser. Somebody has taken away from me. Or I have given to someone. This green laser is still with me. So I have done the small experiment. I show you the prism with which I have done that. Okay. Just a minute. This is a green laser. Okay, and this is the prism, transparent prism I used for the experiment. Okay. And this is the plate for which I've done the experiment. But when you are using this laser, be careful. It's very high intensity. Without any proper goggles, you should not use that. Without any proper goggles, you should not use that. These are all the things we have seen. Let me see. Let me come. I think it has gone to the starting. Just a minute. I'll come back. Yeah, this we have seen. This we have seen. Okay. Good. These experiments I have seen. Light, we have done that. Invisible person cannot see another person. Laser saber, laser pace is not possible. Why the same reason cloud is appearing white, waterfalls appearing white, green tint we have seen, these experiments we have seen. And let me come very clearly. Is oxygen always required for burning? No. Okay. Besides oxygen, there are many chemicals like ammonium perchlorate. That is also best oxidizing agent. Okay. And oxygen alone is not required for burning. Okay. You should have the fuel you should have the material and you should have the heat. Besides oxygen, you can have ammonium perchlorate and other agents like chlorine trifluoride to produce or fluorine. They are all best oxidizing agents. And so the next thing is always oxidizing agent is not required for burning. Okay. In sun and stars, nuclear reactions are taking place that give rise to light and heat, which is not an oxidizing agent. Of course, I am skipping magnetism due to lack of time. One thing I would like to say in magnetism, whatever magnet we are using in a refrigerator doors, the same magnetism is used in induction coil. The same ferromagnetic material is used in satellites. Nowadays, students are very brilliant than us. You are using small satellites. Okay, micro satellites, nano satellites. To stabilize these satellites, these ferromagnetic materials are used. Okay, good. And this, what I would like to drive is, don't worry about this mechanism. Probably many of you would have seen credit card, debit card. You have seen?
Yes, sir.
Yeah. Yes, sir. Yeah, there's a black strip is there now. That is a magnetized strip. That black strip is magnetized, encoded with information. You should not use very heavy magnet like neodymium magnet. You'll be having that black magnets for playing. When you take that magnet, erase over the strip, entire information gets erased. And you can keep this magnet along with your mobile phone because the magnet in your mobile phone is not heavy. The magnetism or the magnet in your mobile phone is not heavy. You can always keep it. But flight ticket, hotel room keys, which is magnetized hotel room keys, those things you should not keep along with your mobiles because the magnetic field of mobile may, perhaps sometimes might collapse the magnetic behavior of the flight tickets. Flight tickets, information is encoded in a magnetic strip. Okay, sometimes in some hotels, you will have a magnetic strip-based log. Those things you should avoid keeping along with your mobile phones. And this is very, very interesting effect, Cheerios effect you can do in your house. Normally, these pins will not attract each other unless it is magnetized, but you can make it to flow. These pins, water spider, coins. Water spider, coins. The objects which normally do not attract each other, but once when it is put in water on the top, it attracts each other. It's called the Cheerios effect. What is the use of this? See, very simple. Why it is arising? Once when you put a material, it is, yes, Harshvardhan?
Sir, if we need to magnetize metal means what we need to do, sir?
You have to keep it with a magnet or apply a magnetic field.
Yes, yes sir.
Yeah,
thank
good.
you.
Thank you, ma. See, this Cheerios effect is very simple. You take this material, normally it should not sink in water. You put it in water, it will create a small dent, and you put another material, same time, it produces a dent. When these two materials, dents comes together, it gives attraction, like it shows an appearance like attraction. Okay, you put Cheerios effect. Some 3 participants raise hand. Yes, your doubt, please.
Sir, sir, I'm Sarani Sri, sir.
Yeah, please.
Sir, you showed before slide the coins were some coins were floating and some coins were melting, sir. Why that some coins are for melting?
Sinking.
Sorry.
I'll explain to you. I'll explain to you. Just give me a minute. Give me a minute. What is the use of this experiment in the sense you can design nano robots, micro robots, because nowadays robotic surgery has taken importance. Some of you might take the profession of medicine. You will be doing robotic surgery. In those times, you can design robots. Yes, Pavitra?
Sir, in this Cheerios effect, the coins will be attracted without magnets.
Yeah. Coins are getting attracted without magnets.
Yes,
I'll show you how. See, very recently, this Cheerios effect is done in mice for drug delivery. They were successful. Okay, they were successful very recently. 24 February 2021. That's a publication from Chinese. They have made use of the Cheerios effect. See, the effect is very simple. You take cornflakes like that, take milk, put the cornflakes on the top of it. Okay, try to distribute all the Cheerios, try to distribute it, they try to attract. That effect is made. This is Cheerios. Okay, that effect, very simple effect. Whenever we are having breakfast, when you have tea, convection, that is connected to black hole, Cheerios is connected to this. Okay, see this experiment I have done. 2 days back, this experiment I have done. This is dhania seeds. Number rasathu use the dhania seeds. And this is pins, they're all not magnetized. As one student asked with me why some coins are sinking. When I place these pins carefully, they float. When I keep it some other angle, that sinks. It will be a very challenging and interesting experiment. You take a big bowl, pour cold water in it, not very ice cold, cold water, don't disturb it. Try to keep the ball pins. Okay, keep a stick for it, try to keep it and then see that. It's very interesting for me. I took some 10-15 minutes time to do this experiment. I didn't try with coins. Maybe I'll try. You can also try with coins, identical 1 rupee coins you can take, big truff you can take, and then you can try, and then you can upload your video in YouTube. Cheerios effect I have done. Okay, practical application. This is done in your house, crumpling paper.
Yes, sir.
Yes, sir. Yes, sir.
Now what you are doing,
Yes,
now you are running out of time. Ah, very good, ma. Very good, ma. After the talk, you can go to your house, in your study room, take 4 papers or 2 papers, 3 papers, crumple it identically and release it. You will see that no 2 papers are identical. It is like fingerprint. Fingerprints of no 2 persons are identical. Like that, no 2 crumpled papers are identical. You will be asking, sir, what is great in this experiment, sir? You crumple a paper and release it and then see that what is great in that, something great. Professor Ramamurthy, I remember he is a neurologist, very famous neurologist in those times where you don't have MRI or advanced X-rays. He is a person who does brain surgery, and in one interview, I think I was doing my 6th standard, okay, some 40 years back. In an interview, he demonstrated, he took some papers, he has crumpled it and then thrown it, and then he said, all brains are not identical. It is like this, while the baby is born, the crumpling is different. It's very interesting. At that time, I do not know. I was studying in Tamil medium up to 10th standard. I do not know these effects. Of late, I got interest. I was thinking, why that professor has said like that? Then the thing is, the interesting thing in this thing is, see here, so many things are crumpled in nature. You have seen that butterfly from cocoon stage? Anybody has observed that?
Yes, sir.
Yes, sir.
That wings, so many big wings are coming. How it is, how it is being enclosed in a small volume, small area. It's a solar sail. It is in a rocket. It is sent, and once when it goes to space, it has to unfold itself like an umbrella. This is a DNA. It is packed into a molecule, into a protein. Flower buds, how they are coming up, how from a small stage, how they are decrumpling. Okay, this is human brain model. Okay, in order to understand this, we are going the reverse way. We take a paper, we crumple it, we decrumple it, and then we see that how it is being made. From that, so many information scientists have arrived. Okay, you can also take some 5 A4 size papers, plain papers, crumple it and expand it with a pencil or with a pen which is not smudging. Draw the lines where all it is crumpled. Compare. No 2 pattern will be the same. You can understand some beautiful mathematics like fractal from this. Okay. So next time when you are crumpling a paper, be happy that you are becoming a scientist. Okay. Okay, students. You're happy?
Yes, sir.
Yes, sir.
Yes, sir.
Because nowadays we are on many wearable devices. Some of my friends, they'll be wearing some watch. I said, what is watch? No, it is pedometer. It is counting the number of steps. It is counting my heartbeat. It is connected to my doctor. It is connected to my wife. It is showing my heartbeat. All those things, because sir, we are all 50 plus. I don't wear any pedometer. Okay. Normally, I want to count by myself the number of walks. Then only my brain will be active. Okay. Fine. These wearable devices, all these things, how to crumple it, how to expand it. Lot of science you can understand from this. Okay. Before that, anybody heard about Edison?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Yeah,
Yes,
who is
sir.
he? Who is he?
He invented
Founder
the
of light,
Invented.
sir.
Yeah,
Founder
yeah.
of light.
Yeah, prolific inventor, prolific inventor, more than 1,000 invention. Who is Edison of India? Anybody? Anybody from Coimbatore can give answer, or anybody from Chennai, or even teachers can give answer for this.
Sir, Darika, sir.
Sorry, ma?
I'm Darika, sir. Sorry, sir.
No. Who is Edison of India?
Gopala Swami.
Ah, very good.
Swami, sir.
Yeah, very big applause. Very big applause. See, is G.D. Naidu. Is an inventor of more than 3,500 applications. He has not patented many. Okay, prolific inventor of India. We have a museum, G.D. Naidu Museum. When somebody goes to Coimbatore, you please visit. A great scientist of India. Okay, then you know this Edison is a man, prolific inventor. And one more scientist I'm going to introduce. Okay, this scientist is called Yoshiro Nakamatsu. He is also a prolific inventor. Okay, very prolific inventor, 90 plus years old. He used to sleep only 4 hours per day. Excellent inventor. Okay, so many things he has invented. 3 great inventors of the world. You can emulate. Okay, you can emulate like them. These are the references I've made. Some 30-40 references. And if you are interested by this talk, and then you say that physics is everywhere, my alphabets: A for atom, B for black hole, X for X-ray, Z for zero-point energy, I'm happy. Other teachers should not feel bad about it. Okay, physics is everywhere. Physics can explain chemistry, biology, and so on. Okay, with the help of mathematics. I am just leaving these 3 questions of homework. You can just mail to me if you are interested. What will happen once when you heat a liquid in the absence of gravity? Does convection takes place? If it is not taking place, why it is not taking place? How heat is transferred? Why the electric pressure cooker is not giving whistle? Is our human nerve viscoelastic material, or a plastic material, or an elastic material? Okay, good. Lastly, I would like to acknowledge my college authorities, my principal, beloved principal, Dr. Shekhar, and my beloved HOD, Samuel Selvaraj, is always encouraging me. Whenever I said when I want to give a talk, they'll say, yes, proceed, do that. Okay. Thing, and my lovely colleagues, Dr. Kandaswamy, Dr. Senthil Kumar, Dr. Mariappan, always very interesting personality. And then I'm thankful to our trustee, Rajesh Kumar Jain sir, who has given very beautiful introduction about science. And then I'm thankful to principal, special thanks to Malati madam, HOD of chemistry, and other staff. Okay, very beautiful comparing by Saranya and vice principal Geetanjali madam, Krishna Lakshmi madam. Okay, and of course I am 1 minute participant. I am thankful to KV Kandaswamy, who is instrumental in introducing me to your school. Okay, he's almost like my brother, and my brother, Dr. Hemant Kumar, who is attending this program from Himachal Pradesh, who is also a very good scientist, and many discussions I used to have with him. He's one of the person who appreciates me in everything. When I have doubt, any basic doubt, sometimes I ask mocha doubts. Okay, he used to sit and explain to me in a very patient manner. Okay, Of course, it has been nearly 20 years. I met him 15 years. I have to meet him again. Good. I'm thankful to these persons. And of course, I'm much thankful to you students for asking so many questions, making the thing very lively. Thank you for your participation. And if you're having any doubts, now you can ask, or if you have any other doubts, you can mail to me or you can message to me. This is my WhatsApp number as well as call. Okay. Lastly, before that, I would like to make a small request, ma'am, to our college school authorities. Normally, I used to take a tree with me, and whenever any school college I'm going to give a talk, I used to plant it. Since we are not meeting, I am requesting you, your college school, to plant a tree and name it as G.T. Naidu memory tree, if possible. Yeah, students, any doubt?
No doubt.
I just send this PPT to your madam. You can share it. Okay. Yeah, just I'll come out of the screen. I'll just come out of the screen. Yes. Yes, please ask. What's your doubt?
Yeah, students, you can put up your questions.
Most of the doubts you got clarified in between itself. If you have still any doubts, you may please ask. Any doubt, not only related to this topic, any general science topic, anything. If I can answer now, I'm happy. Otherwise, I'll get to the answers.
Sir, where does plasma exist, sir?
Yeah, very good question. See, plasma exists in stars, sun. And you have your two-wheeler?
Yes.
Yeah, the exhaust gas is coming from engine, no? The gas which is coming from the exhaust, from the engine, that region is plasma. That region is plasma. But we can't touch it. It will be near around 1500 degrees Celsius. Okay.
Yes, sir. Thank you, sir.
You should distinguish that.
Excuse me, sir.
1 minute. Blood plasma and physical plasma. Physics plasma is different from blood plasma. Okay, you should not get confused. Yes, somebody asked doubt. Yes.
Sir, can you explain about BEC, sir?
BEC.
Bose-Einstein compensate.
Bose-Einstein condensation. Bose-Einstein condensation. Very interesting. It's one different state of matter. See, you have gas molecules. What will happen to these gas molecules in a container? They'll be in random motion. Okay, because of high thermal energy. By some mechanism, you keep on extracting energy from them. At one state, they condense into a single phase. That is called the Bose-Einstein condensation. That is a special state of matter. Fifth state, sixth state. Okay, exotic state of matter. Are you satisfied?
Yes, sir.
Yeah, thank you.
Thank you, sir.
Yeah, come on. No issues. I'm really very happy because today, lot of involvement, lot of questions. Okay, it's really encouraging for me. Your school is very good. Your students are very good, extremely good.
Thank you, sir. Thank you so much.
Yeah, ma'am. Because of
For a
teachers.
wonderful
Okay.
presence, friendly teaching, sir. Very good teaching for our
Thank you,
children.
ma'am. Thank you. Thank you, ma'am. I entered on the teaching lane when I was 21 years old, ma'am. Now nearly 33 years elapsed.
Thank you, sir. Thank you for accepting our invitation. You have given wonderful speech, wonderful demonstration, explanation. Actually, this is eye-opening session, I believe.
I'm really happy, ma'am.
Thank you, sir. Thank you.
But it's taking much time, ma'am, to prepare so much because this PPT culture now, if it is presenting in person, it's different. If it is PPT is making so much time, it's taking up. Ma'am, your mic is muted. Yeah, students, if nothing, no doubts, tell me stop because we will also be tired. If you are having doubt, I'm happy. I can always answer.
Sir, Sir, do you agree with that plasma is the fourth state of matter, sir?
Yes, ma'am. Because see, scientists after doing a lot of investigation, lot of understanding based on thermodynamics, we have classified matter into solid, liquid, gas. Okay. Another state has come up which neither falls in these three categories, neither solid nor fluid. You call it as plasma.
Yes.
Material can be classified in many ways. We have semiconductors, semi-metals, metals, insulators, okay, ionic compounds, based on the electrical conductivity, based on magnetism, okay, many things. Normally, at normal conditions, you will have all those four things. A superconducting material, Bose-Einstein condensate, Fermi liquids, okay. These are all exotic materials, exotic states.
Yes,
Yeah, Pavitra, you raised your hand. Pavitra has raised your hand. Yes, any doubt? As energy is not created or destroyed, how human death occurs? Yes. Very good. Very good question. See, as long as the human system is alive, is active, it is an open system. It takes in energy, gives out energy. Now I breathe, I speak, I perspirate, I give out energy, I take in food. My organs are becoming aged day by day. At one stage it stops. My heart stops, or my brain stops, or kidney stops. Somehow the system stops working. No longer it's taking energy. No longer it's taking energy because it's gradual decay. At one point, all the system stops functioning because it's a beautiful coordination. Are you understanding? It's a beautiful coordination. Human system is very intricate, very beautiful coordination. Even if there is problem in one system, other will not do the job. If some failure occurs, no longer energy is taken in, we call it dead. So that our matter is decomposing, bacteria take up, they take up energy, energy is again consumed. Yes, any other doubts?
Sir, do you think there are any other matters, sir? Do you think there are any other matters than Bose-Einstein condensate?
Yeah, that's what I have said. I don't think, in the sense, scientists have proved many different exotic states of matter. At least 11 to 12 different exotic states are there. But to achieve that, we should have some low temperature or high pressure. Under normal conditions, it will not exist. Okay, liquid helium is there. That is another exotic state. Okay, liquid helium. It will not become a solid. When you keep in a jar, it automatically jumps out. Superfluidity, superconductivity. These are all exotic states. Probably some basic books on material science will give you an idea about this. Some non-mathematical books. Okay, not mathematics oriented. Some basic mathematics book will give you this idea. Thank you.
Sir?
Sir?
Yes.
Sir, why don't we have the sense of pain when we cut the nails or hair, sir?
Yeah, very good question. Very good question. See the hair. Okay, you could able to see me. This position.
Yes.
Position, I don't feel any pain. But when I pluck it, I'll have the pain. The sense, this hair is dead cell, made of keratin. It is not having any nerve or blood or tissue, so that when I cut, I will not feel any pain. Similarly, nail up to this part, when I cut, I will not have any pain. Dead cells. But one beautiful thing with nail, when I have a nail polish on this, many of us are having nail polish. Yes, girls, you are having nail polish. Some of you show your hands. Nail polish போட்டுருக்கீங்களா? அந்த nail polish எத்தனை நாள் இருக்கு? Even if you don't have any, yeah, after that, what is happening? Nail, it's coming out.
It automatically let it off the nail.
Yes. That will not go inside also. Okay. Nail is a very beautiful thing. Why nail polish not absorbed inside? Okay. Why none of the material you are going to put, not you, we. They put ink, indelible ink. And indelible ink will move away from the nail after some time. Okay, it's a very beautiful material. You can think of investigate on it. A wonderful material. Of course, this idea is not my original idea. Some 5 years back, when I attended a conference, that MNIT director, some Rao, Dr. Rao, he was explaining this about nail. It's a very wonderful material. I learned from it. Normally, I learn from many people. I teach to many people. Now, the beautiful thing is when I want to prepare talk for you, I have developed a beautiful idea of candle physics. Already, I had some idea. I have developed a beautiful idea of candle physics. I'm started writing a small book on it.
Sir?
Yes.
Sir, how can we describe the state plasma, sir? Whether it is a state of solid or liquid likewise, sir?
Yeah, see, plasma is a state which is composed of highly ionized molecules. You take a neutral atom, plug out the electrons, what will happen to this? It will become positively charged. This entire system, let us assume this is going to contain plasma. It will have the positive as well as negative charges separated, but together. Highly ionized medium, but electrically neutral. That's called plasma.
Yes, sir.
Okay.
Thank you.
Thank you, ma'am. Yes.
Sir,
Property of earth only, sir.
Property of earth. Earth is solid. It is having liquid. It is having gas. Okay. Solid, liquid, gas. Earth. Yes. Some other question?
Sir, in our
Last
body.
question, children. Children, last question.
Yes, ma'am. Sir, in our body there is the blood as the fluid, sir. Why only the blood is the conductor? We can have water also instead of in our body, no, sir.
Yeah. Very good question. To some extent, I can answer your question. See, the blood is not a single entity. It is having WBC, RBC, platelets, and many proteins are suspended in that. It is a tissue. Okay, it has to transport oxygen. It has to carry out carbon dioxide outside. It has to take oxygen inside. It has to take medicines inside. It has to take salt, calcium, potassium, so on. Okay, that everything is possible by a non-Newtonian fluid. In the Newtonian fluid like water, it is not possible. Okay, that's why God has created blood within us.
Yes.
Okay.
Thank you, sir. Thank you so much, sir.
Yeah, thank you, ma'am. Thank you.
Malati, ma'am.
Yes, ma'am. Yeah, sir.
Yes.
It was a wonderful teaching, sir. Though it was a webinar, you brought this class to live seminar.
Thank you.
The way you started was very interactive and impressive, sir. Children might have played the fidget spinner without the knowledge of science. Now I hope they would have understood that fidget spinner works under the concept of Newton's law, friction. And also, all the demonstrations you have showed were quite interesting, sir. You beautifully integrated the subjects physics, chemistry, and biology, sir. Your way of approaching, clarifying the doubts, and reinforcing were impressed, sir.
Thank you.
Really, it was very active and lively class, sir.
Thank you, ma'am.
It was the way the students wanted it. Of course, we were benefited.
I'm honored because I've taken much time. I'm taken much time beyond time, but I'm sorry for that.
It's okay, sir. Feeling grateful by your words, sir.
Thank you.
Yes. Gratitude unlocks the fullness of life. So, to fulfill this occasion, I would like to call upon Mrs. S. Malati ma'am, Subject Head of Chemistry Department, to deliver the vote of thanks.
Thank you, ma'am. Thank you is the best prayer that anyone could say. I say that one a lot. Thank you expresses extreme gratitude, humility, and understanding. Good afternoon, one and all. On behalf of Bhagavan Mahavir Dayaniketan Jain School and the entire fraternity of the Institute, first of all, my sincere thanks to Almighty God for making today's event a grand success. By His blessings and grace, we are able to make event what it was. My heartfelt vote of thanks to our chief guest, Dr. S. Devashankar, MSc, MPhil, PhD, Assistant Professor of Physics, PG and Research Department of Physics, Loganatha Narayanasamy Government College, Ponneri, who spent his busiest time gracing the occasion. Today, we had the opportunity to hear your thoughts, and this is definitely encouraging us in our future events. Importantly, forced convection, natural convection, using of white petroleum, influence of gravity, types of clouds, and other all concepts also, sir. Thank you. Thank you, sir. I wish to express my gratitude to our trustee, Sri K. Rajesh Kumar Jain, for his encouragement and motivation. I am also very grateful to our trust coordinator, Mr. Suresh sir, for his guidance and support. Special thanks to our Vice Principal, Mrs. R. Geeta ma'am, being the catalyst that inspired us to do our best. I am very happy to express vote of thanks to our staff members who have made this webinar a grand success. I must thank the organizing team, technical team for working hard for the past few days to make this webinar successful. I thank all the parents for their presence this morning. Your encouragement always helps us to carry out important events like this. Thank you all. Last but not least, I thank all the students for showing their interest in the program. I once again thank everyone for making this program successful. Thank you all.
Thank
Thank
you.
you, ma'am.